students. This lesson is going to be on carrying capacity, but now we're going to look at graphs. We're going to look at different types of growth, and we're going to apply the concepts of limiting factors and obviously carrying capacity. So I wanted to start the video with this website. We have seen it in class. It's an estimate of the world population. We're currently at 7,860,000,000 people on this planet. And we are going to use this and also our rabbit population as the example to understand carrying capacity and limiting factors. So let's look at the notes. These notes are posted for you already on Google Classroom. What are the goals? The goals for you today are to, where are the goals? If I can find it. I just had them. Oh, yeah, here it is. The goal, understand the difference between exponential growth and logistic growth, and also read and interpret a population growth graph. So you're going to do that today with a Google form. So let's review. There's various definitions of carrying capacity, but they're all essentially talking about the same thing. So let me read to you the definition. It says biological carrying capacity is defined as the maximum number of individuals of a species that it can exist in a habitat indefinitely without threatening other species in that habitat. Factors such as available food, water, cover, prey, and predator species will affect biological carrying capacity. So think of an environment is basically how many plants, how many humans, how many any other animal can exist there based off the resources that are available, the amount of space, and we can put a number on it. If there's numbers on it, then obviously there's going to be graphs with that. So there's an example of a type of growth. There's two types of growth. There's exponential growth and there is logistic growth. So what is exponential growth? So let me read to you the definition. It says population growth that is unlimited by resource availability, which allows the population growth rate to increase continuously over time, is called exponential growth. This population in this graph is growing very rapidly. There's potentially unlimited resources that's going to allow this population to breed, to reproduce, and produce more and more very rapidly until indefinitely. But you should know that that is not possible. There is not unlimited resources. There's not unlimited food, water, space. There's things called limiting factors that's going to limit the growth rate, is going to limit the population size. So this is not realistic. It's just a model of what could be if we had unlimited resources. So let's look at the realistic graph. This is called logistic growth. Now, this population graph is takes into account the limiting factors, and the limiting factors is going to limit our population to a certain number, which is referred to as a carrying capacity. So let me read to you the definition. It says population growth that is limited by resource availability, causing the population growth rate to slow as the population size increases, is called logistic growth. So here we have a growth rate. Our population is growing, 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 but as you can tell, it sort of begins to slow down and we tend to plateau. We stabilize around a certain number. That certain number is what's referred to as the carrying capacity. This is the maximum number based off the limiting factors that exist in that particular environment. This is realistic. No population can grow indefinitely. There's going to be limits to its growth. So just like always, time on the x-axis and population size on the y-axis. So here's our both graphs, our graphs. Exponential growth, the rate of growth is increasing, increasing, increasing really quickly, and we have a huge explosion of population size. And if this was true, it would just grow on forever. But that's not true. Logistic growth is we have growth right here, grow, 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 grow. Population size increasing. Oh, it begins to slow down. Limiting factors, disease, predators, space, water, food, resources limits our growth, and we hover around a certain maximum value, which is our carrying capacity. This is an example. Sorry, it's blurry, but this is an example of a population. Time is on the x-axis. It goes in 25 years. Populations in millions. As you see, we have a high amount of growth rate, and then it goes up. Overshoot is the maximum it goes. Oh, but then the limiting factors is going to come into play, and it's going to fluctuate, and it's going to stay within a certain number, and that maximum number is called our carrying capacity. So our carrying capacity in this graph is going to be 1.5 million people. Let's just pretend it's people. It doesn't tell us which animal we're dealing with, so let's use people. So in a particular environment, based off the resources, the amount of space, food, water, predation, predator, all that other stuff into play, our environment can only sustain 1.5 million people. That is our carrying capacity. How do I know? Look where the line plateaus, where it flattens, or where it's kind of fluctuating like here. So that's the definition. Carrying capacity is defined as the maximum population size that an environment can sustain indefinitely. For most species, there are four variables that factor into calculating carrying capacity: food availability, water supply, living space, and environmental conditions. So the thing about carrying capacity is that it can be influenced, it can be changed, it could be increased or decreased if you manipulate these variables. So let's say if in this environment we suddenly have more food, tons more food available, more food that allows for more a population size, or our carrying capacity can change weather conditions, water. If you change these variables, you can change the carrying capacity. And you're going to be looking at this in a gizmo, which I'm going to talk about right now. So one of the things that you need to understand is that population no, not population. Carrying capacity can be influenced, and you can change it. One of them is by changing the amount of space. So in class, we're going to look at this. We're going to practice using it, and then you're going to eventually use it for an assignment. So right here we have a gizmo population of rabbits by season, and you're going to manipulate this to see what influence does the amount of land and the conditions have on a population of rabbits. And we're going to practice using this in class, okay? So what I want you to do is I want you to, once I post this, to actually manipulate it. So if you can see here, I'm going to put ample land. There's lots of space for these rabbits, and I'm going to put them in a just normal conditions. So let's see. We're press play. And then here we can see our population numbers of our rabbits through different seasons: spring, summer, fall. That's our table. Here we have bar chart. We can see it's going up, increasing, and then it kind of slows down. And then fall, it's like it goes up a little bit, and then winter, it's like went down a little bit. So you can see the changes. Here's our graph. Look very similar to, I mean, it's a population graph, time and population numbers, and then we have our growth. So you could see it grows, and then it kind of slows down, dips a little, and goes up. So let's wait a little bit. Here you can change it so um, you can see the graph better. So what do you notice about the line? What's it doing? Goes up, dips, goes up. So this is a population graph, and you can see that it's going to look similar to the other graphs that we just went over in the presentation. So we're going to use this, so you better get familiar with it. You can change the conditions Let's give them a harsh winter. Let's see what happens to their population. Harsh winter. Oh, whoa, what's happening there? So here you're going to see the influence of land and environmental conditions on carrying capacity and obviously the population of rabbits. All right, so the last thing you're going to do is you're going to click on this right here, and it's going to send you to a form to see if you understood the lesson. All right, this will be posted on Google Classroom, and I hope you watch it.